we're going to walk through 3 examples where we're going to solve a second-order homogeneous linear differential equation. To make things easier, I've written down the general form for this equation over here on the right, and I've also written down the 2 steps that we can follow. Let's look at our first example. It is y double prime minus y prime minus 6y is equal to 0. In step 1, we want to write down the characteristic equation and then solve it. For this problem, the characteristic equation is m squared, that's because we have 2 derivatives, minus m minus 6 is equal to 0. We can factor this as m plus 2 times m minus 3, set that equal to 0, and this gives us m is equal to minus 2, and then m is equal to 3. For this problem, we have 2 distinct roots. And let's call these roots m1 and m2. The general form for our solution is going to look like y is equal to c1e to the m1x plus c2e to the m2x. Our solution then is y is equal to c1e to the minus 2x plus c2e to the 3x. And that's all there is to it. Let's now look at our second example. We have y double prime minus 10y prime plus 25y is equal to 0. Let's begin by writing down the characteristic equation. That's m squared minus 10m plus 25 is equal to 0. Let's factor it. We have m minus 5 and another m minus 5, and that's equal to 0. This gives us m is equal to 5 and 5. So we have what's called 2 repeated roots. For step 2, let's start by writing down the general form for our solution. Because we have 2 repeated roots, the general solution is going to look like this. Y is equal to c1e to the mx plus c2 times x e to the mx. Our solution then is y is equal to c1e to the 5x plus c2 times x e to the 5x. You could factor out the e to the 5x, but you don't need to. I'm just going to leave our solution just like that. Let's now look at our third example. We have y double prime minus 6y prime plus 13y is equal to 0. Since we have 3 forms of a solution and we have 3 examples, you can probably guess that this one is going to give us complex roots. Let's see. Our characteristic equation is m squared minus 6m plus 13 is equal to 0. Let's now factor this. We definitely need to use the quadratic formula. So m is going to be negative b, so that's minus a minus 6, plus or minus the square root of b squared, that's minus 6 squared, minus 4 times a, which is 1, times c, which is 13. And all of this gets divided by 2 times a, which is 1. Let's see. This gives us m is equal to 6 plus or minus the square root of 36 minus 52. And let's divide all of this by 2. This is equal to 6 plus or minus the square root of 36 minus 52. Let's see. That is minus 16. We divide it by 2. So this gives us 3 plus or minus the square root of minus 16. Let's see. Let's write down that the square root of minus 16 is 4 square root of minus 1, which gives us 4i. So we have 3 plus or minus 4i divided by 2, so that gives us 2i. And these are what we call two complex roots. Our solution in step 2 is going to look like this. Y is equal to e to the alpha x times c1 cosine of beta x plus c2 times sine of beta x. Now let's think about alpha and beta. Alpha is the real part of our complex number, and then beta is the imaginary part. This gives us y is equal to e to the 3x times c1 cosine 2x plus c2 sine of 2x. And there's our solution. If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.